Hello, welcome to Unit 2, Recording 3, and in this unit we are going to be talking about matter and divisions of matter, and we'll also be talking about chemical and physical changes, and also be describing some phases of matter as well. So let's get started. Matter, okay? Matter can be thought of as anything that takes up space or has mass. If it doesn't have matter, it doesn't matter? Well, not exactly, because can you think of something that does not have matter? Energy, right? And so energy is super important in our world, and though you can convert mass or matter to energy, it's not considered to be matter itself. Matter can also be thought of as having the property of inertia, or resistance to change in motion, which is Newton's first law. Objects at rest stay at rest. Objects in motion stay in motion unless acted upon by an outside force. So I always think it's helpful to divide matter up and to do a little chart before we talk about each individual part in more detail. So let's do that. We have matter divided into two broad categories: substances and mixtures. Okay, so mixtures have two or more substances that can be physically separated. Okay, and substances, sometimes we call these pure substances, only have one type of matter, and in these we cannot separate them physically. So within these we have two different categories each. Okay, so within these we have four different categories. We have elements, compounds, under substances, heterogeneous mixtures, and homogeneous mixtures under mixtures. So let's talk about what makes these different. So elements only have one type of atom, and we'll talk about this later, but atoms of an element always have the same number of protons, and so if you change the number of protons, you change the element. So substances have two or more elements. Let's change that to atoms. Two or more atoms. Sometimes they're the same atom, two or more atoms, and we can separate these chemically. Here we can't separate chemically. Okay? And so I'm sure you have your favorite elements and compounds, of course. Girl's best friend is carbon. Compressed carbon makes up diamonds, and gold, right, and maybe silver are examples there. We'll do more examples on the next slides that follow. Water here. Remember I said sometimes atoms can have two of the same atoms to make a compound. Diatomic oxygen that we breathe as a compound. So then we have heterogeneous mixtures and homogeneous mixtures. In heterogeneous mixtures, you can see the phase boundaries. Okay, and in homogeneous mixtures, you cannot. All right, you can separate them, but you cannot see the phase boundaries. So an example of a homogeneous mixture, my favorite would be Kool-Aid. And a heterogeneous mixture might be chocolate chip ice cream. Okay, so that kind of gets us started on this whole subject, and so let's take each one of these components separately and talk a little bit more about them. So the first thing that we're going to talk about is the mixtures that we just highlighted. Mixtures have two or more substances that can be physically separated. Homogeneous mixtures are one in which the substance boundaries cannot be distinguished. Examples of that are lemonade, soda, and vanilla ice cream. Here we have some yummy vanilla ice cream. Chocolate would be also another example of a homogeneous mixture. And then, of course, you could maybe stretch and say that some of the more expensive types of ice cream, maybe you can see the vanilla beans and the vanilla flecks in there, and so you might be able to argue that that is a heterogeneous mixture, but you'd have to describe it rather well to do that. Homogeneous mixtures are also called solutions, and in solutions you have two parts, a solute and a solvent. The solute is the smaller fraction, and the solvent is the larger fraction. Remember, we used Kool-Aid as our example in our previous slide, and so in Kool-Aid, the solutes would be the flavor package and maybe the sugar, right? And then the water would be the solvent, the thing that's doing the dissolving. Okay, heterogeneous mixtures have two or more of the same substance and have a visible boundary. Examples of that would be like chocolate chip ice cream, blueberry muffins, you might do cereal, any number of things there. Most things are heterogeneous mixtures. When you see the matter, you can tell the different parts of the matter that are there. Matter continued here. Substances, okay, when we did our little flow chart, substances were on the opposite side of the divisions of matter, and substances have a constant composition, and they cannot be separated by a physical process. And of course, here we have some examples of gold and water. Gold here, AU for gold, and good old high quality H2O. And these are examples of our different divisions of substances, which are elements and compounds. Elements are composed of only atoms with a fixed number of protons, which cannot be chemically altered. Okay. And then compounds are composed of two or more elements that are chemically bound. In the case of water, we'll talk about this later, they are covalently held in that compound, and you can physically break this apart and you can form hydrogen gas and oxygen gas, and you'd have to have maybe some electricity to actually break that bond. That bond's a fairly strong bond. Changes of matter. Physical changes that do not change the chemical composition of the compound or substance. And so a new substance is not formed. So we have ice melting here as our example. And all the phase changes, melting, boiling, freezing, evaporating, condensing, and all those types of phase changes are physical changes, because you do not change the physical or the chemical composition of the substance. So when you melt water, you still have water. When you boil water, you still have water vapor, and so forth. You can also think of tearing something or polishing something as being a physical change as well. Okay. Melting, freezing, evaporating, along with tearing, bending, and breaking are our examples here. Physical properties are properties that describe a physical change. Boiling point would be a example, or freezing point. Hardness would be an example. Luster, how shiny something is an example. Okay, freezing point, boiling point, hardness, and I gave you some other ones there as well. Changes of matter continue. Chemical changes. Changes that create a new substance. Chemical bonds are broken and reformed. Okay. So we have here examples of burning and rusting and cooking, all things that would form a totally new substance. Chemical properties describe the chemical reactivity of a substance or the chemical properties of a substance. Flashpoint would be an example here. Toxicity, chemical stability would be other examples. Those are a little harder to come up with unless you have maybe some picked out of a book somewhere. Separation techniques. Okay, this is really neat. So how would you separate out mixtures? Well, filtration is the biggest technique used to separate liquids from solids. A mixture is poured over a mesh screen or filter paper that allows the liquid to pass and leave the solid behind. Filtration systems for water are really sophisticated, and they have all sorts of physical filtration systems and then some chemical techniques as well to separate things out. And this is a picture here of a water sewer plant that is filtering water and causing it to become cleaner. One of the most natural filtration systems is swampy areas where you have water that's run through a system of plants and algae and different things that filtrate water. Different mesh size or pore sizes are used for the different size solids. And I think you've probably seen your mom and dad filter coffee, or maybe you drink coffee and filter coffee out. That would be an example of that. The water passes through the coffee grinds and comes out as flavored coffee, but the coffee grinds themselves stay behind. Sewage treatment plant, like the one shown here, is adjacent work. A series of filters and other techniques to purify the water. Very good. Separation techniques continue. This is distillation. It's a process that takes advantage of differences of the volatility of different substances. And so different substances boil at different temperatures because of the dissolved solids in them. And so here we have a distillation equipment set up here. And this is the distillation tube here. And this is a vat of a mixture of some sort, and it's being boiled. And what happens is, in this mixture, certain substances boil off first. And so they have a lower boiling point, so they will boil off and become a vapor, and the vapor goes through this distillation tube and turns back into a liquid. The water surrounding it, or the coolant surrounding it, cools off the vapor and condenses it, and then it's caught back here as a pure substance. And so that's kind of a neat apparatus. They take advantage of this in all sorts of things. They distill alcohol this way. They also have fractional distillation setups for crude oil, so that you can get off the different fractions of crude oil, the gasoline, and the diesel fuel, and so forth. So those are really neat things as well. Okay, so it says here the substance in a mixture that vaporizes at the lowest temperature is condensed in a attached tube and turned back into a liquid and collected. Oil refineries, like I said, do this as well to distill off the fuel oil, the diesel, and the gasoline, among other types of things. Kerosene is another one that they take off. Okay, many other products are used, are made using this process. Chromatography, you may have done some of this maybe in your biology class. I love chromatography. You can separate things off because of the attraction of the mixture, the substances in a mixture to the filtration system here, or the filtration paper in this case. A series of techniques that use a system of two or more states of matter of a stationary phase and a mobile phase. So the stationary phase would be the paper, and the mobile phase would be maybe whatever is put on here. And that mobile phase travels on up, and as the different substances travel up, they have a different affinity for that paper and stick to it. There are many types of chromatography used to separate and identify different types of substances. This is paper chromatography. They also have something called HPLC, which is high performance liquid chromatography. You have two different liquids passing by each other. And you also have something called GC, which is gas chromatography. Of course, mentioning those, but there are many, many other ones as well. Oh, here we go. Got examples listed here: gas chromatography, high performance liquid chromatography. And I used to work in agricultural research, and we would take our soybeans to a lab, and they would extract the oil from the soybeans, and they would run them through a GC mass spec, so they would analyze the fat and carbohydrate profiles. And then sometimes they would even use high-performance liquid chromatography for other types of analysis as well, including some enzymes and that sort of thing. Does the matter continue? Solid phase. Okay, so now we're going to talk about the phases of matter. So the solid phase of matter is one in which the intermolecular forces between the particles are very, very strong. These substances have a definite shape and volume. Okay, so I always give the analogy that the solids are like the little guy at the punch bowl at the high school dance. He's standing there and he's looking across the dance floor and he sees a pretty girl. And he goes, and he shakes, and he's worried that he will be turned down when he asks her to dance. So don't be that guy. Have a little courage. If she turns you down, just ask somebody else. Liquids or intermolecular forces are weaker than a solid, allowing the particles or molecules to slip and slide past each other, but still maintaining contact. These substances have a definite volume, but not a definite shape. Okay, so liquids, I would say, are like swing dancers at the dance, or ice dancers. If you've ever seen the Olympics, they have ice dancing and they have ice skating. Ice dancing, the couples have to hold on to each other. They have to maintain contact. And so this is kind of like a liquid. Liquid particles maintain contact, but they slip and slide past each other. They sometimes can be very deceptive in how much there is in a container because when you actually spread it out, or if it's spread out and it gets into a container, sometimes it's very hard to tell a volume, and that's why in the lab we have graduated cylinders and things to measure precisely the volume of liquids. Gas phase of matter, ones which have very little intermolecular forces when the particles move freely and there is not a definite shape or volume. Gases are like break dancers. Okay, they don't touch each other, they just go wild. They move very quickly. They're more like guys in a mosh pit that are banging against each other. Excuse me. They're banging against each other, and they don't lose any energy. When the gases are in an ideal state, which means that they're not under extreme temperature and pressure, they're very predictive. And we'll talk more about that in our gas law chapter. Okay, this is the last phase of matter, which is called plasma. Phase of matter with no intermolecular forces and they exist. I should read they exist as ions and electrons. And so there is so much energy there that the electrons are stripped away from the atom, and all you have is positive and negative particles, extremely charged particles. And this is the most energetic form of matter that we have. It's the one that's in the stars, and it dominates the universe in terms of percentage of matter. So this concludes our third recording in the unit, and it is the last recording in the unit. In the next unit will be the atom, and in that unit we will talk in more detail about different types of elements, different types of atoms within elements, nuclear forces, and a lot of other really, really cool topics, including a more complicated model of the atom called the quantum mechanical model. So I hope you've enjoyed this unit, and I'm looking forward to seeing you down the road in Unit 3.